Okay, we're going to keep rolling along. This is going to be one of the more challenging ones. This is the cone one. So I'm going to go through this one a little slower, I hope. And I need to get back to where I need to go. Okay, so we're going to share our screen. Okay, so what we got here is we have a tank in the shape of a cone. The cone, it's 10 yards across the top and 12 yards deep. Liquid fertilizer is flowing into the tank at a rate of 5 cubic yards per hour. Find the rate of change of the depth of the fertilizer when the fertilizer is 4 yards deep. Okay, so first thing you need to know, and they will give this to you, volume equals 1/3 pi r squared times the height. Okay, so here is the deal. We don't want to deal with this as like 3 different variables. We want to kind of make this a little bit simpler. So what we're going to do is we're going to rewrite our variables. So what I want you to notice is this. I have a fixed height of the cone, which is 12 yards. If I can figure out the fixed radius, the radius in this case is, this is the diameter of 10 yards, so half of it is 5. So the ratio of the height to 12 is a radius to 5. That is basically a constant. So what we're going to do is we're going to solve for r. We're going to cross multiply. So 12r equals 5h. So that tells me that r is going to equal 5/12h. The reason I do this is the following. I want to rewrite this expression in terms of just the one variable on the right. So 1/3 pi, my radius is 5/12 squared. Sorry, I forgot the h in there. There's an h in there. 5/12 h squared times h. So when I go to expand this out, I'm going to get 1/3 pi times 25 over 144 h squared times h. So my volume is going to equal, when I go to do this, it's going to be 25 pi over 432 when I do the multiplication h cubed. So this is, while it's an uglier looking expression there, it's going to be easier to work with because I just have a v on the left and an h on the right. So now when I read this problem, what I want to say is that the liquid fertilizer is flowing into a tank at 5 cubic yards per hour. So what that is telling me is that dV dt is going to be 5 cubic yards per hour. Now find the rate of change of the depth. So here's the kind of the hook on this one. The rate of change of the depth. As I go down, the rate of change of the depth is technically the height. Depth into the ground is height. So what I'm trying to find is dH dt when the depth is 4 yards deep, when height is 4. So what I'm going to do for this formula is I'm going to take volume equals 25 pi over 432 h cubed. I'm going to implicitly differentiate. Okay, sorry, I didn't want to have the announcement about y'all having to get out of the building in there. Okay, so back to where I was, I'm going to do implicit differentiation dv dt equals, to take the derivative of this, it's 3 times, this is just a constant 25 pi over 432 h squared dh dt. What I'm trying to figure out is I'm trying to figure out dH dt, so I need to have dV dt and h. I do. dV dt is 5, 3. And what I'm going to do is just multiply. 3 times 25 gives me 75 pi over 432 times h squared, so that's 4 squared. dH dt. I want to get the dH dt by itself, so I'm going to divide by this monstrosity of a function. So that's going to tell me that dH dt is going to equal 5 over 75 pi over 432 times 4 squared. And that's going to give me a number, and that number is going to be yards per hour. And that's how I'd leave that answer. I mean, I could simplify it. Some 4 squared is 16. I could find things to cancel out, but realistically, in an FRQ order, call it right there. That's the answer. So that's our answer for the cone one. So the cone one's a little challenging. Next one. Next one is going to be this one. A 25-foot ladder is leaning against the wall. The base of the ladder is sliding away from the wall at a rate of 1 foot per second. How fast is the top of the ladder moving down the wall when it is 7 feet from the wall? Okay, so again, we've done this a million times now. This one is a very common one. So the ladder is 20 foot. That's my fixed distance. I got a right triangle. What I'm going to be doing is it is sliding away from the wall. At the base is sliding away to the wall at a rate of 1 foot per second. So that's telling me that dx dt is going to equal -1 foot per second. Here's my y. How fast is it falling when the base is 7 feet from the wall? So it's telling me how far is it when this guy here is 7 feet from the wall. So I'm not on this side, sorry. When the base is 7 feet from the wall. So from when this distance to the wall is 7 feet. So when x is equal to 7. So we're dealing with, again, Pythagorean theorem. We're going to be dealing with a squared plus b squared equals c squared, x squared plus y squared equals hypotenuse squared. So x squared plus y squared is going to equal hypotenuse squared 25 squared. So in this case, we can take the derivative. So it's going to be 2x dx dt plus 2y dy dt is going to equal 0. I know what x is. X is going to be 7. I know dx dt is -1. I am trying to figure out what dy dt is, so I'm going to need to figure out y. So dy dt is my unknown, equals 0. So to figure that out, what I actually do is I have a triangle. The hypotenuse is 25. The base is 7. I need to figure out that. So what I need to do is I need to figure out what is 25 squared minus 7 squared, because basically, so my y squared plus 7 squared is going to equal 25 squared. So y squared plus 49 is going to equal 625. So y squared is going to equal, what do we get? 49, so it dropped 6, 576. And if you want to, you just grab your calculator and take a look, and I think 576 is perfect square. This is one of the ones I'm not positive of. I think it might be here. So second squared 576. That's 24 squared. Oh yeah, 524, 20, or sorry, 724, 25. So this is going to tell me that y is 24. So I'm going to put 24 in here. 2 times 7 times -1 is -14 plus 48 dy dt equals 0. I'm going to add 14 to both sides. So I'll slide down here. I'm going to find out that 48 dy dt equals 14. I'm going to divide both sides by 48. So dy dt equals 14 over 48 feet per second. So again, that's telling me how fast is the top of the ladder moving down the wall. It's moving down the wall at a rate of 14. It's at a rate of 14 over 48 feet per second. Okay, so that's that one. Number 12. 15. Let's do 15 next. 15. Similar triangles. Another fun one. A 6-foot tall man, that's telling me that this guy is 6, is walking away from a 15-foot tall lamppost, that's this one, at a rate of 5 feet per second. So he's walking away. So it's telling me in this case that dx dt is going to equal 5. So now here's the deal. This is a similar triangle thing. I have this side of the triangle, I have this side to the triangle. 15 is to 6 as this guy's triangle's entire length is y. I need to know what this guy's length is right here. This guy's length right here is y minus x. The whole thing is y. I take away x. This is y minus x. Y minus x. What I'm going to do is I'm just going to simplify this. This is 5 over 2 equals y over y minus x. Cross multiply. So that's going to give me 5. Y minus 5x equals 2y. I'm going to get the y's on one side, so I'm going to subtract 5y. I'm going to get -5x equals -3y. Divide both sides, or divide both sides by -1, so that gives me 5x equals 3y. Now I'm going to do implicit differentiation. So this gives me 5 dx dt equals 3 dy dt. Plug in that 5, so 5 times 5 equals 3 dy dt. That's going to tell me that dy dt equals 25 divided by 3. And what it's going to be is it's going to be feet per second. And again, it's getting larger because theoretically, as you get further away, your shadow gets longer. So that's the answer to that one. That's the answer to number 15. 21. Oh, the airplane one. The fun airplane one. Okay. This one is a next level one. I'm not sure it would be on a test, but I love this question. A plane flying at an altitude of 4,000 feet is flying west at 700 feet per second. So what that is telling me is I got an airplane. Wonderful art again. There's my airplane. It is at a height of 4,000 feet. It is flying west, so I know it is going this way. That's the way it's going. And it's going west at a rate of 700 feet per second. So if you think about it, this is my x. X is going this way. Y is going up and down. So that's telling me his dx dt is going to be negative 750 feet per second. A searchlight is under his path and it tracks the plane. So what it's telling me is that we're on a searchlight down here. How fast is the light pivoting when the plane is 7,500 feet east and overhead? So that's telling me that the searchlight is going to be right here. Again, my super art. There's a searchlight. Let's say right here. You got a right triangle. What it's telling me is that this airplane right here is at the spot 7,500, 4,000. He's 7,500 on the X. He is 4,000 on the Y. This point right here is going to be 0, 4,000. And this guy down here is going to be 7,500, 0. You'll see why in a moment. And we're figuring out this angle theta. So we're figuring out this. Again, if you look at it, what is it giving me? It's giving me stuff over here, which is again adjacent. And thing over here, which is opposite. Opposite and adjacent means tangent. So I'm figuring out tangent theta equals opposite over adjacent. Well, which one of those is fixed? In this case, the adjacent, that height is fixed. That tells me that tangent theta is going to equal opposite, which is x, I don't know, over adjacent, which is 4,000. Again, people like to say the 7,500. We are not going to plug in anything else until we get the implicit differentiation. The only thing we plug in up front is the thing that is constant, and the plane's height is the constant. So now we're going to do implicit differentiation, secant squared theta, d theta dt equals 1/4,000 dx dt. We know that dx dt is negative 750, so we have secant squared theta, d theta dt equals 1/4,000 times negative 750. So again, we need to figure out secant theta, secant squared theta. So from before when we talked about it, secant theta is equal to hypotenuse over adjacent. Because it's 1 over cosine, and cosine is adjacent over hypotenuse, so you flip it over. So that means I need to figure out the hypotenuse. So now here comes the deal. I have a triangle that is 7,500, 4,000. And I need to figure out this. And I'm going to be honest with you, I'm not going to deal with numbers that big. I can actually rethink of this as a different number. So these are both divide by 100. I can actually do that. I can get 75 here. I can get 40 here. And proportionally, the size will stay the same. I'm going to divide by 5. So this gives me a 15. And this gives me an 8. 8. And there is a special right triangle that is 8, 15. It's 8, 15, 17. So that tells me that guy's height is 17. Okay, so when I go to do this problem, and I'm doing hypotenuse over adjacent, I can now say secant theta is 17 over 8. So if I square both sides, I'm going to get that secant squared theta equals 17 squared, which is 289 over 64. So that tells me that this guy is 289 over 64. d theta dt equals negative 750 over 4,000. I'm going to multiply both sides by the reciprocal to get the d theta dt by himself. 64, 289. Leaves me with d theta dt equals, and I'm just going to leave it in this mess it is, negative 750 times 64 over 4,000 times 289. And this is going to be radians per second, because again, we're measuring an angle. Now, here's the deal. Think about it. Negative, this will be a negative answer, but if you think about that searchlight is making the angle bigger. As the plane goes this way, this guy gets bigger. Why is this negative? When the angle's getting bigger, the reason that it is because, oh boy. So, when you actually are going to the left, you're dealing with negatives. A negative angle here, I apologize for that. An angle that is getting larger to the left is getting larger in the negative direction. A negative in the negative direction technically is a positive. So this is actually going to be, how fast is it pivoting? It's pivoting, you really aren't going to say, because it's a negative in the negative direction. That's what it's going to be. So those are the answers. I can tell you that the order was this, so you can actually take a look at it. You went from 1 to 21 to 12 to 10 to 2 to 8 to 5 to 3 to 7 to 11 back to 1. So those are the questions. I wanted to make sure you were able to see the answers. Those are tough ones. I will be honest with you, if we're going to be looking at stuff on quizzes and tests, I don't know if Miss Dash and I will go that hard on them, but just so you've seen some of the challenging ones. Hope that helps.